all to the PACK-NIN webinar series. Today our speaker is Dr. Erwin, and today he is going to present about LCA analysis related to packaging materials. So before moving to the presentation, I would like to give you a short introduction about Dr. Erwin. He is a researcher at the InnoRenew CoE. He holds a PhD degree from Norwegian University of Science and Technology, Faculty of Social Science and Technology Management, and a master degree from the Department of Industrial Economy and Technology Management within the Industrial Ecology program at NTNU. And since 1996, he has been involved in research on the environmental impact of biobased systems and has more than 15 years of experience from different research companies, international institutions, and universities in life cycle sustainability assessment of feed, food, and fiber products like food products, paper, and wood products. From 2013 to 2018, Dr. Erwin performed research and development for the European Commission's Joint Research Center, Italy, on the European Union recommended life cycle assessment method and the environmental footprint, where he led the pilot project developing product environmental footprint category rules for the field of intermediate paper and olive oil. So with this introduction, I request Dr. Erwin to start the presentation, and one request to the participants, if you have any questions, please place your questions in the chat session, and at the end of this presentation, we will address the questions. Thank you. Yeah, the floor is yours, Erwin.
Yes, thank you very much for the introduction. What we are going to see today is about the life cycle assessment and the EU environmental footprint, what it is, a bit about the European paper industry and the technical secretariat. And then we are going into the core, which is the product environmental footprint category rules for intermediate paper products. And then we focus on the packaging paper, then some results. And then we have a look at limitation and discussion and outlook and conclusion. And then at the end, we can have a discussion together. So, this figure shows very nicely what we are up to now. We have some crises that need to be solved. Okay, we survived the COVID-19 relatively good, and everything we have to do there is to ensure to wash your hands, and all will be well. The recession depiction of the economic crisis might be a bit harder, actually, but worst and more life-threatening is climate change and at least biodiversity collapse, because without biodiversity, also the human being cannot survive on Earth. However, we know what we have to do, at least for the climate change, because the science basis, here represented by the International Panel on Climate Change, is very clear. A deep decline in emission of CO2 is necessary. And here we see that the current emissions of CO2 per year is about 40-50 billion tons. And this needs to be reduced to about a half within 2030, and that's only 8 years from now. And in 2050, we have to reach net zero. That means that there should be no emissions, net emission of CO2 in the atmosphere. And after that, we have to suck atmosphere from the CO2 from the atmosphere and burn it in stable underground or other stable reservoirs for CO2. And this brings me to life cycle assessment, and here I have found a definition from the European Environment Agency glossary. Life cycle assessment is a process of evaluating the effects that a product has on the environment over the entire period of its life, thereby increasing research use efficiency and decreasing liabilities like economic or environmental costs. It can be used to study the environmental impact of HR product or the function the product is designed to perform. And the function here is quite important. We will further look into that one later. LCA is commonly referred to as cradle-to-grave analysis. LCA's key elements are, first, identify and quantify the environmental loads involved, for example, energy and raw materials consumed, the emissions and waste generated, evaluate the potential environmental impacts of these loads, and third, assess the options available for reducing these environmental impacts. That's very short what is LCA. Then I come to the environmental footprint, which is further specified in this recommendation from the European Commission. This is the latest update. First was in 2013, then this latest update came in December 2021 on the use of the environmental footprint methods to measure and communicate the life cycle environmental performance of products, that's PEF, and organizations, that OF. We will have a look at the PEF for the product and related to packaging product. So these are something that is specified in this recommendation in the PEF, the life cycle impact assessment indicators. First, of course, climate change is often a focus, but there are many more. And we see here eutrophication, human toxicity, acidification, ozone depletion, ecotoxicity, ionizing radiation, photochemical ozone formation. Land use and water depletion is important for biobased products, and of course, research depletion like fossil fuels, etc. So, why do we need environmental footprint? And the short answer to that is, why do we need to get closer to comparability of life cycle assessment research and decrease time and cost? Because without any guide, as you see here in the top of the pyramid, it's very flexible, but highly variable and ad hoc decisions. And therefore, it also takes much more time and it's more costly because you don't have pre-described the decision. You have to take them all. However, in the ISO 1440 and 1444, this is on life cycle assessment, which is the international standard. This is a good framework, but there is not enough technical details. So we have the ILCD handbook, which is the previous version, so to say, of the environmental footprint. And this is very technically detailed, but not always easy to apply. And actually, it's very long because it's a series. The International Reference Lifecycle Data System, it's a series of books. I think it's about 10 or 12 books. So it's very, very detailed and very long. So then we have the environmental footprint that provides some detail, but needs to be applicable to all products. And that's why we have at the end here product category or sector rules that are more specific. They are relevant, efficient, and cost effective. So we are going to increase reproducibility, comparability, and consistency by providing technical details, choices that limit variability, and clear guidance. So the intended application of LCA and environmental footprint studies, they can be used in-house to support environmental management, identify environmental hotspots, improvement and performance tracking, and may implicitly include cost savings opportunities. The external application of LCA and PEP studies is responding to customer and consumer demands that we often hitting, of course, also benchmarking, where you can compare to a benchmark, Environmental labeling is also very useful. Supporting eco-design throughout supply chain, green procurement, and responding to requirement posed in environmental policies at the European level or at the level of individual member states or countries. And when the PEF study is intended for external application, a specific PEFCR is either recommended, where there is communication without comparative assertion, or mandatory, where you do comparative assertion. So let's go to the pulp and paper production in Europe. I have an overview of that, where we have pulp and paper production sites. They are more or less spread over all of Europe, with of course the largest one in Finland, Sweden, and quite many also in Central Europe. So then a bit on the organization and the members of the technical secretariat. Those are the people or organizations behind that develop this PEFCR for intermediate paper products. We have SIG, we have Stora Enso, Metso, Tetra Pak, International Paper, Smurfit Kappa, Sofidel. There are some large paper and packaging producer. We have the WWF. This is a large environmental NGO. We have universities, Utrecht University and Norwegian University of Science and Technology. We also have some certification organizations and a lot of other that is not included here. So then we go into the product environment footprint category rules for intermediate paper products and look at the product category and system boundaries, the results and limitation and discussion. So the product category intermediate paper product is a manufacturer product material. It's used as an input for producing paper products for different end-use application. It's used in communication, newspaper, and other graphics paper, packaging, which we are especially interested in today, and also sanitary and hygienic, also called tissue paper. And the term intermediate is used to make difference between paper material and paper product. For example, newspapers, corrugated packaging, or kitchen towel. And also, I think it's worthwhile to think about intermediate in terms of packaging paper, because packaging is not the final product itself. Usually, it's used to protect another product during transport, for example. So just to say that final products are not included in this product category. And that's also mean we don't include end of life, but I will come back to that. So, and then we have in this product category, we have 3 different subcategories: graphic papers, including newsprint, packaging paper, and tissue. Those are the 3 subcategories. They have a classification code. They are the same. C1712, and the CPA code is also C7012. And all CPA subcategories included, except specific CPAs. For example, handmade paper is not included. It was too specific. So this is the system boundaries. We have here in red the cradle to gate system boundary. That is of interest. We have the raw material acquisition for the background system, where we have paper for recycling, and we'll come back to this. We have wood from forest, we have water, energy wares, and auto materials that is going into the core process with the foreground system of production of pulp. And this can be done mechanical, chemical, or with recycled materials. And we then have production of paper and paperboard, 3 different types: graphic, packaging paper, and tissue. And after that, we also have the further life cycle of the paper, which is converting manufacture of paper article, which is actually what you see as a packaging, can be a card box. And then the distribution used is then when this packaging is used to protect the product, and the end of life, which is collection of paper for recycling, energy recovery, incineration, or disposal in the downstream processes, which is the back-end system. So that's the system boundaries. Then we'll go into the declared unit, which also called functional unit, which is an essential term in SA, because it's all the results are related to this declared or functional unit. And in the case for intermediate paper, it's 1 ton, 1,000 kilo, of saleable paper grade at the mill scale. And when you do a PEF study following this PEFCR, you also have to specify the paper weight, moisture content, which is usually about 5, but it can vary a bit, code or grade of the paper. The functional unit or declared unit of different intermediate paper products shall not be compared unless additional specification that ensure comparability are set. And this is because it's only an intermediate, it doesn't look at the whole life cycle. However, there are additional functional unit or declared units that may be used, for example, 1 square meter of pulp. And this is relevant for graphic and packaging paper. Some results from the main findings of the screening study. And the screening study is a PEF study of representative or average European products that we did all together in the technical secretariat. And the main result there was that out of more than 1,000 elementary flows, only 23 elementary flows has been identified as most relevant. As part of 42 relevant flows, which covers all impact categories. So that's quite amazing that we found from more than 1,000 elementary flows that could be water, could be zinc, could be all kind of elementary flows, a term for something crossing the physical boundaries between the nature and the technical sphere. And we found that only 23 elementary flows are most relevant, and there are 42 others that are also relevant. And with that, you actually have most of the impact. Further, we found that most of the relevant issues and effects are common to all 3 types of paper, but some elementary flows are specific only for 1 paper grade. But not others. So, for example, for graphic paper, it was minerals. Packaging, which we are interested in today, there it was starch production, and the starch production used in packaging paper comes from agriculture, produce, for example, potatoes or maize. Or for tissue, it was the chemicals. Further results from the screening study was that use of primary data is recommended for the core processes, which are the pulp making, de-inking if included, paper making process, and pulp production paper making integrated mill, where you often have primary data together, so to say, for the integrated mill. Further, we found that biodiversity is a highly relevant additional environmental information, and we'll come back to that. And the most relevant process, pulp and paper production, and their electricity, energy mix, and the chemicals additives used in paper making. Also, important result, all 16 default environmental footprint impact indicators, as I showed you in the beginning, shall be included, because it's an intermediate and we don't know how this will look like when you have a product packed into this packaging paper. So, okay, so to continue some results on from the same study regarding recycling and benefits. There, the PEFCR says that we should actually give two different results. One with 100% benefit of recycled input material, and the other where we apply a material-specific allocation factor. A, it's called A. I will come back to this. But it's for packaging product is 0.2. And this research shall be reported as additional technical information and allow further use in downstream application to create environmental footprint compliant data sets. Okay, so I promised to come back to the recycling. How to handle the recycling is specified in the environmental footprint guidance methods. They have a formula for in general, and here I show it for intermediate packaging paper products, not including end of life, because we only look at the intermediate. And visualize this formula in a better way. So, so we look at two product life. One in blue is the product life N-1 is the previous one, and then we have the product life N, which is where you want to do a PEP study, where and this use recycled paper. So recycling here is a shared process. So recovered paper from after the use phase in product life N-1 is going through the recycling process, and this recycling process is producing pulp, recycled pulp, for the production of new packaging paper. So, and then we have environmental burden of the recycling process. Of course, we have environmental burden of virgin material, pre-processing, which is the forestry and pulping. And then R1 is the proportion of recycled material. So how much of the total pulp is recycled and how much the rest is then virgin pulp that goes into the production. And then this formula tells how we can allocate the recycling burdens and benefits to the product life and in orange here. And we find again this 0.2, which is the A for packaging paper here in the formula. And the rest is then 0.8, which is then for the virgin materials. And it also says here that if you use a lot of or everything of 100% recycled material, then this will be very low. Actually, in that case, 100% it will be 0, this first part here. But you will have some burden from the very first virgin materials production, because you need, you can't have a recycled paper without forestry and pulping in a previous slide. Okay. And also promise to come back to the additional environmental information. This is not commonly part of LCA or the environmental footprint, but it's reported separately. And in principle, in general, sustainable production of biobased materials shall be considered at all relevant stages in the life cycle and requires sustainable management to be certified by performance-based standard or otherwise demonstrated technique to indicate or demonstrate are achieving or surpassing a particular performance level. It might include calculation of soil organic matter, biogenic carbon flows or stock exchange, for example, land use, or harvesting disturbance impact on biodiversity. So, shortly about the limitation and outlook, we had some data gaps related to PM10 and PM2.5 that was not everywhere measured. Carbon flows on the forest level are not included, and chemicals with partially unknown composition. Outlook is, of course, PEFCR for paper products like packaging, including end of life, because for now only intermediate products and the big paper rolls are included. And this is also important for the circular footprint formula on the recycling. A value not equal to 0.5 there might be problematic. And as for package paper, we have 0.2, so let's see what that will mean. And of course, all case studies from the industry are very welcome to get some insight in the real application of the PEFCR. To conclude, we was able to reduce the cost for LCA with 80 to 90% thanks to the common rules, but also free environmental models, free secondary data, and IT tools. The PEFCR on intermediate packaging products can be used by the industry on a voluntary basis, and the policy implementation on the EU level is still under discussion. Okay, I'm not going into the sources of further reading, but thank you all for your attention, and I hope you have some questions. Thank you very much.
Is there any questions from audience? Okay. Okay, no. So I can ask a few questions. So for example, when we develop a bio-based composite material, we have a plan to perform the LC analysis. So in this case, what are the inputs we need to consider to perform the LCA and how to fix the functional unit? So can you give some points on this topic?
Yes, for bio-based product, it depends on if they are from agriculture or forestry, but that will for sure be an important input. And then the processing into the material you would like, that's something to decide on, to look into. And then the next question, you have two, haven't you?
Functional unit and functional unit.
Oh, yes. That's an important question. And then you really look at if it's a packaging product, you will need to look at what services does your product do for your product. I mean, that's the main, is to protect.
Yes, it's true. We are out of everything.
Sorry, some background.
I'm sorry. Yeah, what is?
So the functional unit, you will really need to look at what service is your packaging providing. And that, from that you will, I mean, how long is it going to stay protecting your product, for how long, and okay, and the rest of the function, maybe you have some, if you have food product, there are specific requirements to food packaging, for example, and if there is maybe protect from rain, there is another function. So all those kind of, if you really go into the functional unit, you have a job looking at the product you want to pack this product into, and then yes, really sit down and look at the services you need. Okay. So that's for the functional unit. Thank you.
Thank you. And another question is, for example, when you stated your slides, you mentioned that the recycled fibers used, and also you added some virgin fiber. So how much percentage of recycled fibers introduced in the product life end? And is that enough to produce a good quality packaging material and the fiber strength and all those things? Do you have any idea about that?
Yes, I know from the European average a few years ago when we started this work, it was about 75% recycled paper for the packaging paper. I mean, there are different qualities, but they use 75. And for the strength, I mean, usually in this recycling product, the slow fibers that are the short fibers that are too short, they are taken out. So there is a loss there. I'm not sure exactly how much, but it's around 10, maybe 15% or something like that. That is taken out because they are too small, and that's of course to have the strength necessary.
And you included the consumer behavior at the end of the cycle, like.
We didn't look at that, but so much I mean, when recycling packaging paper, it's, I mean, many or maybe the most is going directly from the shop back to the recycling paper mill. If it goes via the consumer, I know that it often gets wet because it's standing outside in the rain before being collected. So that was one thing I remember, that it's normally more wet than what you can get directly from the shops. But regarding the quality, except for that, I'm not sure. I mean, the pulping process is quite good to separate out what you don't need, because that's also a problem when you have consumers throwing in the wrong bin things that should not be there. But they are quite good to sort that out in the process, the pre-sorting and so on. So I don't have impression that that's a big problem, but for sure it will be better to have, and it's more expensive also if you have good sorted grades. So that's they like the best directly from the shop because it's more clean and so on. Yes.
Okay, thank you. And we received one question from the audience. How many times can packaging paper be recycled? How much more becomes waste in each recycling phase?
Yes, I tried to answer a bit on that one. So I think it's about 10% that is lost every time. So that means, or maybe 15, around that range. And that means it can be recycled about 6-7 times. And the waste is then this 10 to 15% every time, yes.
Thank you, Tasa, for the good question. So are there any more questions from audience? Okay. So one final question. Can we perform this LCA analysis with open software like OpenLCA? Is that enough, or do we need to have any additional software to get the data sets for the input informations? Is that necessary? Is that compulsory to have some paid softwares to get all the inputs?
Yeah, there are softwares that are opened. That's not the problem. There are, for example, OpenLCA, which is quite good one. There are also more specific tools. But what you need is a background database, and they are not open. I mean, the one is if you want to do a product environmental footprint following the EU environmental footprint methods, then they also have some open data, but then you really have to follow the methods and do a PEF study. Then you can use the data there, but they don't have everything you need, but for sure they have for all products where there is PEFCR. But if you go away from that, I will say you will need a background database that is not open access. Yes, but the software is fine, and you can do some small studies. But to do a real LCA, you will also need some background that you have to work with.
Okay, thank you. Okay,
Yeah.
thank you very much for the very nice presentation and answering all our questions. So thank you, audience, and let's see in the upcoming webinar series. And thank you very much, Erwin, for joining us today.
Thank you very much, Drew.
Yeah,
Bye
thank
bye.
you. Bye bye. Thank you.